In the bone-dry highlands of southwestern Ethiopia, where rainfall arrives like a broken promise and droughts can stretch on for years, there is a place where people have been feeding themselves without interruption for over 400 years. No irrigation pumps, no chemical fertilizers, no government subsidies. Just stone, soil, and a system so quietly effective that the outside world spent decades calling it primitive before UNESCO declared it a World Heritage Site. This is the story of the Konso people and their terraced trench gardens, a story about what happens when you build something that actually works, and what happens when the people who dismissed it are finally forced to pay attention. The Konso are a Cushitic-speaking ethnic group of roughly 350,000 people, living at around 1,650 meters elevation, south of Lake Chamo, in an area that climate scientists classify as semi-arid and hostile to agriculture. Hostile. That is the word used in the literature, and yet, for over 4 centuries, the Konso have been farming this hostile land and feeding their communities through every drought cycle the region has thrown at them. Their oral traditions trace their arrival to this landscape roughly 21 generations ago, and some researchers believe elements of their land management knowledge are even older than that. They did not stumble into survival, they engineered it. To understand how, you first have to understand where they live. The Konso do not live in scattered homesteads. They live in fortified hilltop towns called polycultures, engineered settlements encircled by up to 6 concentric rings of dry stone walls. These are not decorative, these are defensive, organizational, and agricultural infrastructure rolled into one. The walls define the community defines the land, and the land is shaped, every square meter of it, by the most extensive system of hand-built stone terraces in the Horn of Africa. The numbers alone are staggering. The Konso terraced landscape covers over 230 square kilometers, more than 55,000 acres of hillside, transformed into productive farmland through dry stone construction. Some of these terrace walls reach 5 to 8 meters in height, reinforced with carefully stacked stone buttresses and turrets that would not look out of place in a medieval fortification. But these walls are not built for war. They are built for water. Every terrace functions as a catchment basin. When the seasonal rains come, and they come hard and fast when they come at all, the terraces slow the runoff. They prevent the kind of catastrophic soil erosion that strips bare hillsides down to bedrock in a single season. They capture water and hold it, allowing it to soak deep into the soil profile rather than rushing downhill and disappearing. And when there is too much water, the system discharges the excess in controlled ways, preventing flooding while preserving every usable drop. What the Konso built is not a garden. It is a landscape-scale water harvesting machine made of stone. Between the terraces, the Konso plant a deliberately diverse polyculture. Sorghum, maize, cotton, coffee, moringa, and various drought-resistant crops are intercropped and rotated with a precision that Western agronomists are only now beginning to document and understand. This is not random planting. This is calculated redundancy. If sorghum fails in a drought year, moringa survives. If maize struggles, deep-rooted varieties hold. The system is designed so that total crop failure is essentially impossible under normal drought conditions because there is no single point of failure. The Konso do not bet the farm on one crop. They never have. The system extends beyond the terraces themselves. Communal water reservoirs called harda are built near sacred forests and maintained through collective labor organized by the Hila age group system and the Kanta ward social structures. This is not one farmer tending one plot. This is an entire community maintaining an entire watershed. The sacred forests near settlements are not incidental. They regulate local microclimates, prevent further erosion, and serve as reserves of medicinal plants. The stone walls themselves create thermal mass that moderates soil temperature and reduces evaporation during the hottest months. Every element connects. Every element has a function. Nothing is decorative and nothing is accidental. Research published in Current Research in Environmental Sustainability in 2023 confirmed what the Konso have known for generations. These indigenous soil and water conservation practices have demonstrably sustained agricultural productivity across centuries of documented drought cycles. The terraces work. They have always worked. The question worth asking is why it took so long for anyone outside the Konso to notice. The answer is uncomfortable, but it is not complicated. For decades, outside development agencies, colonial-era anthropologists, and even post-colonial Ethiopian government programs looked at Konso farming and saw what they expected to see: primitive subsistence agriculture. The word primitive appeared in descriptions going back to the early 20th century. When Father Azais documented the Konso Waga memorial statues in 1931, the agricultural system surrounding them was largely overlooked or dismissed as background. The statues were exotic enough to warrant attention. The terraces were just dirt and rocks. The development paradigm that dominated the mid to late 20th century made things worse. The Green Revolution was the gospel. Monocultures, chemical fertilizers, hybrid seeds, mechanization. Everything the Konso system was not. The Konso built walls by hand. They planted dozens of crops together. They organized labor through kinship and age-grade systems rather than market incentives. In the eyes of development economists and agricultural extension officers trained in Western institutions, this was everything backward. Multiple development programs attempted to introduce so-called improved farming methods to the region. They brought the inputs, the expertise, and the institutional confidence, and they failed. They failed because they did not account for the specific hydrology of the landscape, the particular behavior of the soils, the brutality of the rainfall patterns, or the centuries of adaptation the Konso system had already undergone. The modern methods were designed for flatlands with reliable water. The Konso live on steep hillsides in a semi-arid zone. The mismatch was total. C.R. Hallpike's 1972 ethnography, The Konso of Ethiopia, studied the people's social structures and values in considerable detail, but it framed their practices through the lens of traditional versus modern, a binary that implicitly positioned Konso knowledge as pre-scientific, as something that existed before real knowledge arrived. This was not unique to Hallpike. It was the default framework of an entire era of anthropology and development studies. Indigenous knowledge was filed under tradition. Western knowledge was filed under science. And tradition, in that framework, was always the thing that science was supposed to replace. When someone calls a 400-year-old, drought-proof, community-built agricultural system primitive, the word tells you more about the speaker than the system. In the vocabulary of development discourse, primitive has historically meant something very specific. It means the system does not require purchased inputs. It does not generate profit for outside companies. It does not fit neatly into Western agricultural models, and it was not invented by people with university degrees. By those criteria, the Konso terraces are indeed primitive. By every other meaningful criterion, they are among the most sophisticated landscape engineering systems on the African continent. The Vindication, when it finally came, was unambiguous. In 2011, the Konso Cultural Landscape was inscribed as a UNESCO World Heritage Site, the first place in Ethiopia recognized specifically as a cultural landscape rather than a natural wonder or a historical monument. UNESCO did not use the word primitive. UNESCO called the terraces a spectacular example of a living cultural tradition that demonstrates outstanding engineering knowledge and represents a major human achievement. The language matters. Spectacular. Outstanding. These are not the words you use for something primitive. Modern soil science has since confirmed what the Konso always knew. The terraces dramatically reduce soil erosion. They increase water infiltration and retention. They support higher crop diversity and greater food security than comparable non-terraced land in the same climate zone. A 2023 study published in Sustainable Development specifically examined how Konso indigenous agricultural knowledge integrates with and in many cases exceeds modern permaculture principles. A 2024 paper in Scientific Reports documented Konso adaptation strategies to climate variability and found that indigenous practices, including terracing, are the primary resilience mechanisms against worsening drought in the region. The Konso did not need these papers to validate what they built, but the papers exist now, and they say what the Konso have been saying all along. This pattern is not unique. West African terrace farming by the Mafa, Dogon, and Ngas peoples was dismissed before it was studied. Inca andenes in Peru were treated as archaeological curiosities rather than functioning technology. The Ifugao rice terraces in the Philippines were admired as scenery long before anyone took the engineering seriously. Aboriginal Australian fire management was criminalized before it was recognized as the most effective wildfire prevention system on the continent. The cycle repeats with grinding predictability. Indigenous systems are dismissed, ignored, or actively suppressed until a crisis proves them right, and then the same institutions that dismissed them begin publishing papers about how remarkable they are. But here is where the story turns, and not in the direction you might hope. The greatest threats facing the Konso terrace system today are not droughts. The terraces have survived those for 400 years. The threats are modern. Urban expansion beyond the traditional walled towns is breaking up the terrace landscape. Youth migration away from the land is severing the generational knowledge transfer chain that has kept the system alive. The Konso zone has experienced ethnic violence and displacement, with hundreds of thousands of internally displaced persons. The United Nations flagged Konso as a priority humanitarian hotspot in 2022. Young people facing economic pressure and limited opportunity are converting agricultural terrace land into stone quarry sites for construction, dismantling the very infrastructure their ancestors built stone by stone over centuries. A 2025 study published in Discover Environment specifically characterized meteorological drought and its impacts on the Konso cultural landscape, and found something that should alarm anyone paying attention. Elders are losing the opportunity to pass indigenous terracing knowledge to the next generation. The knowledge is not written in textbooks. It lives in the hands and memory of people who learned it from their parents, who learned it from theirs. When that chain breaks, it does not repair easily. You cannot download 400 years of landscape engineering from the internet. The Konso trench garden system is not a relic. It is not a museum piece. It is a functioning, living technology that modern permaculture and regenerative agriculture movements are only now beginning to understand and attempt to replicate. The Konso are literally still farming the same terraces their great-great-great-grandparents built. In similar climates around the world, modern monoculture farms collapse in a single bad season. The Konso system has not collapsed in 400 years, 4 centuries of drought survival, 0 external inputs, a UNESCO World Heritage designation, confirmation from every branch of modern soil and water science. And still, the institutions that once called it primitive are only now catching up to what the Konso understood before any of those institutions existed. The terraces do not need the experts, they never did. The question now is whether the world will learn from them before the last person who knows how to build them is gone.